Okay, so chapter 3, section 1 deals with plotting points in a coordinate plane. So here is a coordinate plane. It's formed by the intersection of, oh geez, sorry about that, formed by the intersection of two lines, a horizontal line called the x-axis and a vertical line called the y-axis. These two main lines intersect at a middle point referred to as the origin. And that actually has the coordinates 0, 0. Now, the x and the y axis, the way that they intersect, they kind of create four sections, which we call quadrants. Okay? So there are four quadrants of the coordinate plane. This is quadrant 1, quadrant 2, quadrant 3, and then finally quadrant 4. So it starts in the upper right, and then you move counterclockwise from there. Points can be represented on the coordinate plane. So any location on the coordinate plane, like this location here, or this location here, or over here, all of these points can be represented with what we refer to as an ordered pair. Ordered because the x comes before the y, and a pair because it involves two numbers, something in for x, something for y. So anytime you want to plot a point on the coordinate plane, or locate a point, or identify the ordered pair that a particular point is, you always start with the origin. So let me get rid of this. So to plot points, so plotting points, you always start at the origin. So start at the center. And then remember, all ordered pairs, all points, can always be represented with some value for x, comma, some value for y. So the x value pertains to the x-axis. It tells you how much you move right or left. So you move right if x is positive, and left if x is negative. And then once you do that, then you look at the y value, and that tells you if you move up or down. So the y value, you move up if y is positive, and down if y is negative. Okay, so those are going to be, that's what you want to follow. So example 1 in your book, or I'm sorry, actually guided practice 1 in your book, or sorry, guided practice 2, or number 3. Oh, geez. Number 3 through 6 in the guided practice of 3.1 on page 147 in your book asks you to plot 4 points, A, B, C, and D. Point A is the point 2, 5. Point B is the point -1, 0. Point C is -2, -1. And then finally point D is -5, 3. So it asks you to plot the points and then identify the location of the points on the coordinate plane. So starting with point A, the first value of x is 2. So remember, we always start at the origin. And from the origin, the 2 tells us we're going to move right 2. So we end up here, but we don't plot anything on the 2. And then the 5 tells us to move up 5. 1, 2, 3, 4, and 5. So that's where we land. We go over 2, positive 2, up 5, and that brings us to point A. The location of point A would be in quadrant 1. Point B, again, start at the origin to get to point B. Negative 1 is the value of x, so that tells us to move left 1. So that's negative 1. And then we just stay there. We're not moving anywhere up or down. So that's actually point B right there. And the location isn't in any of the quadrants. It's actually on the x-axis. And so that's the location of point B, is on the x-axis. We can also plot points C and D. I'm just going to go ahead and erase these though for now, give us some room. Oops. Okay. So point C, starting with the origin, negative 2 tells me I'm moving left 2, and then the negative 1 tells me I'm moving down 1, ending at this point here. So this was negative 2, negative 1, brings me to point C, which is in quadrant 3. And then finally point D. So once again, starting with the origin, moving to the left 5, 1, 2, 3, 4, 5, because 5 is negative, and then up 3, because the 3 is positive. So negative 5, up 3 lands me right here at point D, and point D is in quadrant 2. So the next thing we're going to look at is graphing a function. This is actually number 7 in the guided practice of chapter 3, section 1. And this asks you to graph the function y equals negative 1/3 x plus 2 with domain negative 6, negative 3, 0, 3, and 6. So if you recall from chapter 1, domain always refers to your input values or your x's. And then the second part of this this problem is to not just graph it given that domain, but then identify the range as well. And so the range are always your output values, the y. So a good way to do this is to take your domain, remember those are your x's, those are your input, create a table. Okay, so we're going to be plugging in negative 6, negative 3, 0, 3, and 6 for x. And then we need to find y. We need to find the corresponding y values, so that will give us the points to graph this function with that domain. So the y given by the function is equal to 1/3 times x plus 2. So all we have to do is take the function and replace x with the given values, the given domain. First, negative 6. Negative 1/3 times negative 6 is 2, plus 2 is 4. So when x is negative 6, y is 4. That's a point. That corresponds to the point negative 6, 4. Then we plug in the other values. Negative 3, 0, 3, and then finally the 6. And so by plugging in negative 3 here, negative 1/3 times negative 3 is 1, plus 2 is 3. This will give you 2, 1, and then finally 0. So when x is negative 3, y is 3. When x is 0, y is 2, and so on. Okay, so those give you corresponding values, and each pairing of x and y is a different ordered pair. So we had negative 6, 4, then the pairing of negative 3 and 3, 0 and 2, 3 and 1, and then finally 6 and 0. So to graph this, we simply graph those points. The point negative 6, 4 would be here. The point negative 3, 3 is going to be here. 0, 2 3, 1, and then finally 6, 0. And so that's the graph of the function y equals negative 1/3 x plus 2 with the given domain. We do not connect the dots because we're asked to graph the function with a specific domain, so they stay and remain isolated points. If we were asked simply to graph the function in general, then we would get a line. But in this case, we are restricted by a specific domain. And so the second part of this problem was to identify the range. Well, the range are all the values you got for y. And so that would be 4, 3, 2, 1, and 0. Basically all of these values right here. And so that's how you graph that function.